So today we're going to finish up on this thing about area of polygons, and it's going to get pretty intense at a couple times because this is actually one of the trickier things that we do during the year. However, it's also one of the things that brings together a lot of the topics that we've seen, including SOHCAHTOA and trigonometry, as well as solving triangles. So it's a neat review for the exam at the same time, and it brings up topics that you haven't seen in a few weeks and brings them back into the forefront so that you get a chance to review and study these things. First off, let's just look at our theorem. To find the area of a regular polygon, and remember the idea of regular means that all the sides are the same and all the angles are the same, so it's only these special polygons. But the area is 1/2 times the apothem times the perimeter. So the two things we need to know in order to find the area of a regular polygon is I need to know the length of the apothem, and I need to know the length of one side. Because if I know the length of one side, I can quickly find the perimeter by just multiplying by the number of sides, right? That's easy. Now, what we did yesterday is we broke that polygon down, just as a very quick review. We took that polygon, and I'll do an octagon here, and we broke it down by drawing in our diagonals. Those are the radii of the polygon, and within each set of diagonals we get an isosceles triangle because the radii are congruent, which means that this is a right triangle and it splits the side in half. That's half of a side. S/2, we'll call that, half of a side. We also learned very quickly how to find the measure of this central angle, because that central angle is really simple. That central angle is just 360 divided by the number of sides. And this angle right here has to be half of a central angle, because the isosceles triangle, we drop the altitude in. So this angle is half of a central angle. And we didn't talk about a formula for that, but honestly, if we take 1/2 of my formula, we could get the formula 180 divided by the number of sides. So that's this angle. And if this angle is 90, we can quickly find this angle as well. So then all I need is one of these measurements, either the radius, half of a side, or the apothem. And if I know an angle, I can use SOHCAHTOA to set up and solve my triangle. And so what we're going to be doing is we're going to be consistently taking our polygon, whatever shape it is, and we're going to be breaking out this right triangle. And the measurements of that right triangle in every case, okay, and this is going to be really important. You're probably going to want to jot this down. The measurements of this right triangle that we're going to use is that this angle is 180 divided by the number of sides. It's half of a central angle. And once we know that angle, then I know that this side is the opposite of that angle. This side is the hypotenuse. This side is the adjacent. And I like doing that because the adjacent is also the apothem, so the A's and the A's go together. And we can go ahead and solve that triangle using SOHCAHTOA and our trig techniques. So it's a pretty straightforward process once we get that done. Let's take a look at an actual example here. Here I have a nonagon. Nonagon means 9 sides. Inscribed in a circle, the radius is 4. So again, what we're going to do is we're going to break out that special triangle in the inside. Whoops, another line. Now I know the radius here is 4. That's the hypotenuse of the triangle. I don't know these other two measurements. I need to solve for this half a side. I need to solve for the apothem here. But this is the opposite. This is the adjacent. This is the hypotenuse. I do need to figure out this angle. This angle is going to be 180 divided by the number of sides. In this case, 9. So that angle is 20 degrees. If I need to know the angle down here, that's easy to find because they have to These two have to add up to 90, so this would have to be 70 degrees. Not that we need to know that, and not that we're going to use that. We're going to stick with the central angle because, again, that keeps the adjacent and the apothem being the same letter, A and A, which is kind of nice. Because this adjacent side is the apothem. And this opposite side is 1/2 of a side of the polygon. Now that we've got that set up, we just go ahead and set up our sine, cosine, tangent. Now, depending on what we're given, here we're given the radius or the hypotenuse. That's going to affect which functions I'm going to choose to use. Sometimes we might be given the opposite side. Sometimes we might be given the apothem or the adjacent side. It really kind of depends on what the problem tells us, how we set things up. So, again, I'm going to go sine of 20. And if we have so katoa, sorry, don't need that little extra mark after the H and the ka. There we go. Sine is opposite over hypotenuse. The opposite is unknown, so we'll call that x, over the hypotenuse, which is 4, and that's easy to solve. 4 times sine 20 equals x. Now, obviously, we do need a scientific calculator for that. So we get out our scientific calculator and go 4 sine of 20, and it's about 1.37. Take it to a couple, when it's that small of a number, we'll take it to a couple decimal places. If it was a large number over 10, we'd probably take it to only 1 decimal place. But we'll go 1.37 here. For the adjacent to the apothem, I'm going to call that side A. And again, it's adjacent hypotenuse, so that's cosine of 20 equals adjacent over hypotenuse, which is 4. So 4 cos 20 equals A, which is the adjacent and the apothem, the way we set this up. So 4 cos 20 is 3.76. And now I've got everything I need to know to calculate my area. So the formula for area is the apothem times the perimeter divided by 2. Well, I don't quite have the perimeter yet, but I do know that half a side here, remember what we figured out is just half a side, okay? Half a side is 1.37. And there are 9 sides to this polygon, so there are 18 half sides, or we could double it to find the length of a side. So let's just take it times 2 to find the length of a side. So that's going to be 2.74. We have to multiply that by 9 sides. And of course, my calculator is going to handle that for me. 2.74 times 9, 24.66. So there's my perimeter. And we get apothem, so we just plug our numbers into the calculator, 3.76 times 24.66 divided by 2, and I get the area as 46.36 units squared. Yep, it says units, so units squared is the area. There's my context. We're going to repeat this procedure a couple more times in practice. Because that's really all we're doing today is doing this. Now, again, this angle, the 20 degrees, is going to change depending on our number of sides. But the setup really doesn't. Here I have a table as an octagon. The sides are each 15 inches long. And the radius of the table is 19.6 inches. Find the area of the tabletop. Well, if I know each side is 15 inches and there are 8 sides, I mean 8 times 15 is pretty easy. That's 120. So I already know my perimeter is 120 inches. That's nice. And when I break down my triangle here, because we always have our triangle, This one's actually going to work out pretty nicely because I already know that this is 19.6 inches. I know a whole side is 15, so this is 7.5 inches. I do not need to use SOHCAHTOA here because I already know two sides of my right triangle. Finding the third side of my right triangle is a relatively simple task because we can use Pythagorean theorem. And again, we get a squared plus b squared equals c squared. A is the apothem in this case, which is fine. A squared plus 7.5 squared equals 19.6 squared. Now remember, we do have to square first, order of exponents. So a squared, 7.5 squared is 56.25. 19.6 squared is 384.16. We subtract the 56.25 from both sides. So a squared is 327.91. And take the square root of that. And I get about 18.1. 18.1 we'll take it at, because everything else is 1 decimal points. Okay? So we've done that, and we found the length of our apothem. So now I can just plug, because I have my perimeter, I have my apothem. My area is apothem times perimeter divided by 2. Now I'm going to make my life easier here, reduce that, because that reduces so easy. And I get 18.1 times 60, or 1,086 inches squared. Why would that be important? Again, if you're tiling that tabletop, you need to know how many square inches you need to cover. Okay, you have 1,086 square inches of tile. Find the area of a regular polygon. A couple of them here for you. I am not going to give you a whole, I'm only going to give you one problem today to do on your own. So there's only one quiz problem, and let's make it this one, number 5 right here. Okay? So why don't you work on that? It's just like the one we did with the tabletop. The only difference is there are only 5 sides this time. You're going to have to solve, a little hint here, you have to find that length and then use that to find the area. And let's make our unit centimeters. Okay? Give it a shot. Number 6, again, I have a side. I got to count my number of sides. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my perimeter is 70, and we'll call it centimeters. And I'm going to bust out my triangle again. Ooh, that was terrible. That's why I shouldn't freehand draw. Now the 7 represents a whole side. So since this on my triangle is half the side, that's going to be a 3.5. The angle here is going to be 180 divided by the number of sides, because half of a central angle. Since the number of sides is 10, that's going to be 18 degrees. I know the perimeter. I need to know the apothem. Half a side is the opposite side. The apothem is the adjacent side. Opposite adjacent is tangent. So the function I set up is the tangent of 18 is opposite over adjacent. Remember, when my variable's in the denominator, I swap these two values. And I go to my calculator for that. 3.5 divided by the tangent of 18 is 11.7. So then my area winds up being my perimeter times my apothem divided by 2. And again, I could reduce first. So 35 times 11.7, or 409.5 units squared. Okay? One more time. Area of a stop sign when the side length is 8 inches. A stop sign is what type of shape? You got it. It's an octagon. Side length is 10 inches. So if I draw my triangle in here now, I'm kind of guessing a little bit, but that's okay. It's probably further than the center. We'll go there. Okay, so there's my triangle. So this is going to be 5 inches. This is my hypotenuse. This is my adjacent and my apothem. And this angle is 180 divided by 8, which is 22.5 degrees. And that's exactly 22.5, so we'll leave it there. This is the opposite side. Just like the last example, opposite and adjacent are in play. Hypotenuse really isn't important to us right now. So opposite adjacent is tangent of the angle is the opposite over the adjacent. So the adjacent, or the apothem, is 5 over tan 22.5. So 1 or 12.1 approximately. So now I got my area is a perimeter. Each side is 10, so my perimeter is 80, times the apothem divided by 2. And I'm going to, again, since it's such a nice number, I'm going to simplify that. So 40 times 12.1 is 484 square inches. In a stop sign there, each side is 10 inches long. All right. There are a lot of examples there. You may need to refer to them a few times. Make sure you check the notes, not just the podcast online. Schoology has these notes. You can print them off if you want some more example problems. Hopefully you also copy these down into your notes, because this is some pretty involved stuff. Many, many steps involved, but great review. All right, we'll see you in class.